Welcome, and let's continue with our lessons in integral calculus. Today we're looking at how to integrate products of sine and cosine. In this lesson we'll be integrating the product of sine ax times cos bx. This is sine ax raised to n and cos bx raised to m. So we'll be very much interested with the exponents here, because in today's lesson we're looking at both exponents being odd, or if one of the exponents is odd. So we'll be looking at such products. But in our next video we'll be looking at integration of the same product of sine and cos, but at that time the exponents n and m will both be even. So today we're just looking at if n is odd. If n is odd, how do we integrate that? And if m is odd, how do we integrate that? What if n and m are both odd? How do we integrate that? So that is what we're interested with in today's video. Now, so that's what I've just stated here. I've said that to integrating products of sine a theta raised to n and cos b theta raised to m d theta, where one of the exponents, either n or m, is odd, or they're both odd. Now, so I just want to state a few things that we'll be looking at, the rules that I'll be considering, that if the exponent of sine is odd, if the exponent of sine is odd, we'll be stripping out one sign and converting the remaining signs to cosine using the identity sine square theta plus cos square theta is 1. So this identity will be very much useful in the entire video. Now, so that is what happens if the exponent of one sine is odd. That we strip out one sign and convert the rest to cosine. The same thing would happen if the exponent on cosine were odd. So if m is odd, then we strip out one cosine and convert the rest to sine using this identity. Now, what if the two are both odd? What if n and m are both odd? So if n and m are both odd, then we can use any of the above methods. That we can strip out one sine and convert the rest to cosine, or we can strip out one cosine and convert the rest to sine. But of course, there is an easier way of doing. We look at the smallest exponent. If they are both odd, we'll consider the one that is smaller. And supposing n is smaller than m, then that means we can replace this. So we strip out one sign and convert the remaining signs to cosine. But if m is smaller than n, we do the same thing. We strip out one cosine and convert the rest to sine. So let's just look at a few examples to make this to understand the concepts that I've just talked about. Let's look at a few examples. So the first example is this, and it's very important that we take it seriously, because the other examples, the way we perform this, will help us understand the rest of the examples. So we are integrating sine x raised to 8 multiplied by cos x raised to 3 dx. So I've said that we go to, for the one that is odd. So the exponent that is odd is the one of cosine. So since cosine is the one that is, the exponent of cosine is the one that is odd, we'll strip out one cosine and convert the rest to sine. So this is what we write. This is the same as sine of x raised to 8 cos x raised to 2 and then cos x dx. So we've stripped out one cosine is here, and these remaining cosines we convert them to sine. So we say we know that the identity says that sine x squared plus cos x squared is 1. So what this means is that cos x squared is 1 minus sine x squared. So that's what I write here. It will be the integral of sine raised to 8x, and then this is the 1 minus sine x squared multiplied by cos x dx. So at this point, we'll say that let sine x be u. Let sine x be u. So where there is sine x, we write in u. But now let's differentiate. On this side, we'll have the derivative of sine will be cos x dx, and the derivative on this other side will be du. So make dx the subject. If you make dx the subject, we'll have dx being the same as du out of cos x. So we substitute u where there is sine, and we substitute du over cos x where there is dx. So what do we get? What we get will be u raised to 8 into 1 minus u square, and this is cos x, but instead of dx we have du out of cos x. So this cos x would cancel this, and what do we have? What we have here is u raised to 8 minus u raised to 10 du. We can now integrate this. We can now integrate this to get. We can integrate this to get u raised to 9 out of 9 minus u raised to 11 out of 11 plus t. Plus t is the constant of integration. Now, so what was u? That just replace u was sine x. So replace, where there is u, replace sine x. So what do we get as our final answer? Our final answer will be sine raised to 9x, sine x raised to 9 out of 9 minus sine x raised to 11 out of 11 plus c. So that's how we integrate this. And I had already done it, so let me just show you the steps. I'll just be showing you the steps that we'll be using. So I had already done this question, and this is what I did. What I did was, from our introduction, we remember that its cos, the exponent of cos, is the one that is odd, and therefore we strip out one cosine and convert the rest to sine. So that's what I did, strip out one cosine, convert the rest to sine. So this way I'm converting the rest to sine. Because of course this cos x squared is the same as 1 minus sine x squared. The rest remains the way they are. So at that point, I let u be sine x, and then differentiate on both sides to get it. U is cos x dx. So that I know that from here I can make dx the subject to be dx to be the same as du out of cos x, and then come and substitute. And then come and substitute inside there. So that's what I did. That's what I did. So while there is sine x, I'm writing u, writing this u, and while there is dx, I'm writing du out of cos x. So this will be u raised to 8 into 1 minus u raised to 2 cos x So that's what I'm writing here. And then instead of dx, it's du out of cos x. That those cancel. And you have this, and you have that. And then you just replace the equivalent of u. U was sine x. U was sine x. So just substitute it. And you have the final answer. Remember to add the constant of integration. Remember to add the constant of integration. We want to look at another example so that we get familiar with this kind of integration. So let's look at this other example. What is very important to us is to identify the one that is odd, and then we strip out one and convert the rest to the other trigonometric ratio. So in this example, we can see that 5 is odd. So the exponent of sine is the one that is odd. So we strip out 1, and I've done that. I've stripped out 1, it's here, sine x, and I have sine x raised to 4, and then cos x raised to 4. So this is the one I want to convert to cosine. I want to convert that cosine. Remember that what we have is that sine square x is 1 minus cos square x. What I have here is sine x raised to 4. Sine x raised to 4 is the same as sine x raised to 2 square. So in other words, this is the same as 1 minus cos x raised to 2 square. The same as that. Because what I have is sine x raised to 4. Sine x raised to 4 is the same as sine x raised to 2 square. So that's why you see this coming in. That's how this comes in. Now at this point, we now let u be cos x. Let u be cos x. So if you use cos x to differentiate both sides to find the u being negative sine x dx, and then make dx the subject of the formula, which will be du out of negative sine x. We are now ready to substitute. Because we're using substitution method, we are ready to do that. So let's just proceed and substitute. Remember that where there is cos x, we write in u. So we have sine x into 1 minus u squared, and then square the whole thing, and then u raised to 4. But instead of dx, we have du divided by negative sine x. And that negative is here. So this sine x cancels this sine x. We are left with the integral from 0 to pi out of 2 of 1 into u square, 1 minus u square squared u raised to 4 du. So you work out this one first. Let's just do it here. So it's 1 minus u square squared, which means you're multiplying by itself. But when you multiply, it's 1 times 1, which gives us 1, and then 1 times u square, which gives us negative u square, there's a negative here, and then negative u square times 1, which gives us negative u square, and negative u square times negative u square, which gives us positive u raised to 4. And this is 1 minus 2u squared plus u raised to 4. And that's what you see me writing instead of this. You see me writing that instead of this. And then I multiply by u raised to 4. But remember there's a minus here, minus 1, which will also affect the contents inside the integral sign. So let's see what I got. in the next step. So it's here. So I decided to take that minus outside the integral sign and just to show you the two. This minus, I decided to take it outside the integral sign, and I told you that instead of this, I'll write 1 minus 2 u raised to 2 plus u raised to 4, then multiply by this u raised to 4. Now we can do this. We can multiply by u raised to 4. So u raised to 4 times this one is u raised to 4. U raised to 4 times negative 2. U raised to 2 is negative u raised to 6. And u raised to 4 times u raised to 4 is u raised to 8. We can now integrate at this point. We integrate at this point. Remember how we integrate? We add 1 to the power and divide by the new power. So when I integrate this, I'll get u raised to 5 divided by 5. This negative has come in as this negative inside. There's no problem. And then this will be 2 u raised to 7 out of 7. And this will be u raised to 9 out of 9. So when I do this, I multiply this negative. This is what I get. And I have to remember that I'm doing it from 0 to pi over 2. Now, in our previous video, we had learned how to change the limits. You may want to change the limits to be those of u, because the ones we have are for x. The limits you have 0 to pi over 2 are for x. So you may want to change to have them be of those of u so that you've completed this point. But for me, I'll maintain these limits. I'll maintain these limits. But if you want to see how to change the limits, you can check our previous video on integrating by changing limits. Now, so since we are not changing limits here, in our case, let's bring back what was u. U was cos x. So where there is u, we write in cos x. So this will be cos x raised to 5 out of 5. There's a negative there. This will be 2 cos x raised to 7 out of 7. And this will be negative cos x raised to 9 out of 9. And then from 0 to pi out of 2. So when you put your limits, you get 8 out of 315. Get 8 out of 315. Of course, you know that. Let me just tell you that you must be knowing that when we write sine x squared, this is just the same as sine of x raised to 2. So I'm doing this so that it's easier for you to use your calculator. But at this point, you're just doing negative cos, where there is pi, where there is x, you write in pi over 2, then raised to 5, then over 5. So you can use your calculator. Of course, pi is 180 degrees. Divided by 2, that's 90 degrees. So we're talking of cos 90, and then the answer that we get, raise it to 5. The same thing here, cos 90, the answer that we get raised to 7. Then multiply by 2 over 7. Same thing to that. Let's look at another example. And this example, both exponents are odd. Both exponents are odd. I can see that the exponent on sine is 5, which is odd, and the exponent on cosine is 3, which is also odd. And so, where both exponents are odd, we can either, you may decide to strip one sine and convert the rest to cosine and proceed the way we've done in the previous examples, or you may decide to strip one cosine and convert the rest to sine and proceed the way we've done in the other examples. But for me, the easier way to do it is to check which of the two exponents is smaller. So in our case, 3 is smaller. And since 3 is smaller, so it's now easier for me to strip out one cosine and convert the rest to sine. And that will make my work easier, like if I were to do this. So that means that I would have the integral of sine x raised to 5 cos x raised to 2 cos x dx. And then convert this to sine. And I know that this is the same as 1 minus sine x raised to 2. So that's what I have. That's what I have. So let's just see what I did. So this way we've stripped out one cosine, and we will know the reason. We'll say that because the exponent was odd and was smaller than the other odd exponent here. So when we convert this to sine, this is what we have. 1 minus sine x raised to 2 was that. Then at this point, we let u be sine x and differentiate on both sides to get du equals to cos x dx. And make the x the subject of this, and that will be equal to du out of cos u. du out of cos u. So let's just substitute. And where there is sine, write u. So this means u raised to 5 into 1 minus u raised to 2 cos x. But instead of dx, write du out of cos u. du out of cos u. So that cos u and cos u cancels. And what you're left with will be the integral of u raised to 5 into 1 minus u raised to 2 du. You can expand this by multiplying u raised to 5 inside this bracket. So when you do that, you get u raised to 5 minus u raised to 7. Just do that inside the bracket. U raised to 5 minus u raised to 7. And then you can now integrate this, add 1 to the power divided by the new power. Adding 1 to 5 will be 6 divided by 6. Minus, add 1 to 7 will be 8 divided by 8. Plus constant integration. So bring back your u. Bring back your sine, because u was equal to sine x. So bring back your sine x. While there is u, write sine x. So this will be sine x raised to 6 minus sine x raised to 8 over 8 plus c. And that's how we integrate this. Now let's look at where there is no product. That we only have sine, or we only have cosine, and that the power here is odd. Remember that we're not doing when the power is even. When the power is even, we'll do it in another video. So when the power is odd, you must bring cosine. You must bring in cosine. So just like the same way we did, you strip out, because it's already odd, you strip out one sine, convert the rest to cosine. That's what I did. So this is sine x raised to 3 dx. Strip out one sine x, and then it will be sine x and sine x squared dx. Convert this sine x squared to cosine. And I know that sine x squared is the same as 1 minus cos x squared. So bring that in. You must bring it. You must have cosine coming in whenever you are doing this type of integration and you are only given sine. So let's see now how to proceed from here. We've stripped out one sine, and we're now converting the rest to cosine. Now let u be cos x. Let u be cos x and differentiate on both sides. When you do that, the derivative of u will be du, and the derivative of cos x will be negative sine x dx. Make dx the subject to be du out of negative sine x. So where there is dx, of course, we'll be writing this. And where there is a cos x, we'll be writing u. So we come back to this. We have sine x, I write it there, into 1 minus u squared. Instead of dx, you write du out of negative sine x. So that this sine x cancels this. And this negative, I take it outside the integral sign. I would have negative into the integral of 1 minus u squared du. At this point, we can just integrate and bring back our cosine x. So when we integrate, remember there is negative, the integral of 1 will be u, the integral of 1 to u will be u, and the integral of of u square will be u cubed out of 3, and then plus constant of integration. So when I multiply by this negative inside, I would have negative u plus u cubed out of 3 plus c. But what was u? U was cos x. So where there is u, just write cos x. This will be negative cos x, and this is plus cos x cubed divided by 3, then plus constant of integration. And I think we should do another example where we are only given one trigonometric ratio to integrate, and the exponent is odd. Yeah, so this time we are given cos x raised to 5, and of course we have the limits. So let's do it. 5 is odd, so we'll strip out. We'll strip out to have cos raised to 4x, and then cos x. And remember the limits, 0 to pi out of 3 dx. At this point, convert this to sine, and you know that cos x raised to 4 is the same as cos x raised to 2 square, which is the same as, and the one in the bracket is 1 minus sine x square. The one in the bracket is this. So what about if I include this other square? This is what I'll be having. That cos x raised to 4 is the same as 1 minus sine x raised to 2 square. So this is what we'll be seeing me write instead of this. It's here, cos x, and instead of this, I'm writing 1 minus sine x square, the square of that, dx. I'm supposed to substitute this dx. So I begin by saying that let u be sine x. Let u be sine x. Now, if u is sine x, differentiate on both sides to have du is cos x dx, and make dx the subject of the formula, which will be du over cos x. And then come and substitute here. That where there is sine x, write u. So I have cos x into 1 minus u square, the square of that. Instead of dx, write this. So this is what I have. Cos x 1 minus u square, the square of that, du over cos x. Cos x cancels. So what I have, the integral from 0 to pi out of 3. Now just square this. And we had squared it before, and we found 1 minus 2u squared plus u raised to 4 du. And then integrate. Then integrate. So when you integrate 1, just a minute, just delete this. When you integrate 1 du, you get u. When you integrate 2u squared du, you get 2u raised to 3 divided by 3. And this one gives you u raised to 5 divided by 5. And remember the limits. Now at this point, bring back your, was it cosine? The one that, no, it was sine. We had said that let u be sine x. So bring back, where there is x, where there is u, write sine x. So let's bring back our sine. So when you bring back your sine, this you will have sine x here, then minus 2 sine x cubed divided by 3 plus sine x raised to 5 divided by 5, and the limits are 0 to pi over 3. Now put your limits. Of course, you know to put the limits. You put the upper limit, get an answer, and then put the lower limit, get another answer. Subtract those two answers. The answer that you get from when you substitute the lower limit is subtracted from the one that you get when you substitute the upper limit. So what I'm talking about is this, that we have sine. When I substitute the upper limit, I would have pi out of 3 minus 2 sine x, that's pi out of 3 x cubed, then divided by 3, then plus sine pi out of 3 is raised to 5, and then divided by 5. That's when I put the upper limits. The answer that I get here, I must subtract from it this answer. Sine, instead of x, I'm putting the lower limit, and then 2 sine 0 raised to 3 divided by 3 plus sine 0 raised to 5 out of. And when you do that, this is what you get. Now let's do another interesting. This is now a bit interesting. Remember that now this is not just x, it's 2x. This is 2x. I want to see how to do that. But what is interesting here is that the exponent is odd. The exponent is odd. So you must put out just the same way we had said before. It will be sine 2x raised to 2 and then sine 2x dx. Convert this to cosine. What I know is that sine 2x squared plus cos 2x squared will give you 1. Sine 2x squared plus cos 2x squared will give you 1. So using that, we would change this to cosine. Change this to cosine. So what I'm expecting to see going forward is that this, instead of this, we will write 1 minus cos 2x squared. Then this one the measure it is. So let's see what I did. Yeah, that's what I did. I saw that this was odd. the exponent was odd, so I stripped out one, and I have this other one which I converted to cosine. You can see this one I've already talked about. Then dx. At this point, I let u be equal to cos 2x. And we know how to differentiate these trigonometric ratios, that the derivative on the left will be du, and the derivative on the right will be negative 2 sine 2x dx. So making dx the subject of the formula, you would have du out of 2 sine 2x. Now let's substitute. That where there's cos 2x, we write in u. So this is sine 2x, it's still there, into 1 minus u squared. Instead of dx, we're writing this. You can see it here. This sine 2x cancels that. So I have a constant inside here is negative 2, 1 over negative 2. So what do I have from here? This is what I have. 1 minus u squared times negative 1 out of 2. You may want to multiply this through or put it outside the integral sign. But what I've done here, I've multiplied through first. I've multiplied through. So when you multiply through what you have, I would have negative a half. Then this negative and this negative will give me positive a half u raised to u 2 du. This is what I have here. And then just integrating this negative a half du gives you negative a half u. And integrating this is a half u raised to 3, then over 3, which gives you raised to 3 out of 6. And then plus constant of integration. Of course, go back to where u was and discover that u was equivalent to that and substitute it here. Substitute there. So what do we get? What we get will be negative a half. There's a u here, so our answer is cos 2x. Then plus 1 over 6 u cubed. But I will use this cos 2x cubed plus constant of integration. Then let's look at this other one also. We just want to see how to do these integrals. The many examples we do, the easier it becomes for us. This is odd. We strip it. When you strip 1, you would have cos 3x raised to 4, and then cos 3x. We convert this to sine, and we know this. We know that cos 3 raised to x raised to 2 plus sine 3 raised to x, no 3x raised to 2 gives you 1. So this means that cos 3 raised to x raised to 2 is 1 minus sine 3x raised to 2. What do I have here? What I have here is cos 3x raised to 4. So cos 3x raised to 4 would be the same as the square of this. The square of this. So it will be 1 minus sine 3x raised to 2, the square of that. So this is what we'll be seeing me substitute here. You see me substitute this one here. And it's here. That this one remains what it is. But instead of this, I have this. 1 minus sine 3x raised to 2 square dx. So at this point, we say let u be 3x. Let u be sine 3x and differentiate on both sides to get du equals to 3 cos 3x dx. Or that dx is du out of 3 cos 3x. We are ready to substitute and then integrate. So let's just substitute. Where there is sine x, you write u. And where there is dx, you write du out of 3 cos 3x. So that's what you see here. That cos 3x is still there, but this is 1 minus u squared. Everything is squared. Instead of dx, you're writing du out of 3 cos x. Where cos x cancels that, and we are left with 1 minus u squared. The square of that times a third. So it's easier, first of all, to square it. When you square this, you get 1 minus 2u squared plus u raised to 4. Then multiply that by a third. There's a du here. Multiply that by a third. So when you multiply by a third, it's when you get what I have here. What I have here is a third, and then this will be negative 2u squared out of 3, and this will be u raised to 4 out of 3. Now integrate this by just adding 1 to the power and dividing by the new power. So when we integrate that, the integral of a third will be a third u, and the integral of this would be this out of 9. The integral of this would be u raised to 5 out of 15, and then our limits are 0 to pi over 2. You can never put these limits because before you bring back the sign, because you want to change the limits. So you must bring back the sign 3x. You must bring back the sign 3x to get this. Now let's have the last example. Let's have the last example. And we have this. This is odd. So we strip 1 out and convert the rest to sign. And so that's what I did. So you can look at the workings here, but of course you can try to do it on your own and then compare your answer and mine. Try to do it on your own and compare your answer with mine. That's how we do integration of a product of sine and cosine, where the exponents are either all of them odd or one is odd. Thank you.